Yesterday we set up our pentesting lab. Today we start using it, but not how you might expect. Before we scan anything, before we send a single packet to our target, we're going to learn everything we can about them from public sources. This is passive reconnaissance, and experienced pentesters will tell you it's the phase that makes or breaks an engagement. The quality of your passive recon directly determines how effective your active scanning and exploitation will be. Let's start with the basics. Passive recon means gathering intelligence without interacting with the target's infrastructure. No port scans, no web requests to their servers, no DNS lookups against their name servers. Everything comes from third parties who have already collected the data. WHOIS databases, search engines, certificate logs, Shodan. The target has zero visibility into what you're doing because you never touch their systems. This matters for two reasons. First, there's no detection risk. No IDS alert, no firewall log, nothing for a SOC analyst to investigate. Second, your rules of engagement might restrict active scanning to specific windows, but passive recon can start the moment you sign the contract. The first tool I reach for is amass in passive mode. Run amass enum-passive-d and your target domain. It queries dozens of data sources simultaneously: virus total, common crawl, the Wayback Machine, certificate transparency logs, and more. On a real engagement against a medium-sized company, this single command regularly turns up hundreds of subdomains. Why do subdomains matter? Because organizations lose track of them. That staging server someone spun up 2 years ago for a demo? Still running, still unpatched. The Jenkins CI server that was supposed to be internal only? It got a public DNS record and nobody noticed. These forgotten assets are often your best entry points. Now let's talk about certificate transparency logs. This is one of my favorite passive recon sources. Every time a public certificate authority issues an SSL cert, they're required to log it in a public, append-only log. You can search these logs at crt.sh. Type in a domain with a wildcard prefix, and you get back every subdomain that has ever had a certificate issued for it. The key insight here is the word ever. Even if a subdomain was decommissioned years ago, if it had a cert, it's in the logs permanently. I've found internal tool names, acquisition targets, and development environments through CT logs on real engagements. One time, I discovered a Jenkins instance this way that had default credentials. That single finding from passive recon gave us initial access without any active scanning. Google dorking is the next technique. Most people know about the site: operator, but the real power comes from combining operators. Try site: your target domain, then file type :env or file type :yml or file type :conf. You'd be surprised how often configuration files with credentials get indexed by Google. Other useful dorks: search for entitle "index of / to find open directory listings. Search for inurl:/swagger or inurl:/API docs to find API documentation that reveals every endpoint. Search for the company name plus password or secret on GitHub to find accidentally committed credentials. Even if the developer deleted the file, GitHub's history keeps it, and tools like Trufflehog can find those deleted secrets automatically. Shodan is another critical tool for passive recon. Shodan continuously scans the entire internet and indexes what it finds. When you search Shodan, you're querying their database, not scanning the target yourself. Search by organization name and you get back IP addresses, open ports, operating systems, software versions, and sometimes even default credentials visible in service banners. I want you to understand why this is so powerful. A single Shodan query can tell you that a target is running Apache February 4, 49 on 3 servers. That specific version has a path traversal vulnerability, CV 2021-41773. You just identified a potential exploit path without sending the target a single packet. Combine Shodan results with your subdomain list from amass and CT logs, and you have a detailed infrastructure map. The last technique I want to cover is metadata extraction from public documents. Companies publish PDFs, Word docs, and spreadsheets on their websites. These files contain metadata, author names, which become usernames. Software versions, which tell you about their patching. Internal file paths, which reveal directory structures. Download public documents from the target's website and run exiftool against them. The author field in a company PDF often contains a Windows username like Smith. If you've already determined their email format is firstname.lastname from LinkedIn Ascent, that becomes john.smith at the target domain. Now you have a valid email address for password spraying. Here's the thing about passive recon: the skill isn't in running these tools. Anyone can run amass and theHarvester. The skill is in connecting the dots and prioritizing findings. A forgotten staging subdomain matters more than 100 employee email addresses. An exposed Git repository is more valuable than knowing their web server version. Train yourself to spot the anomalies, the things that shouldn't be public. Organize your findings into categories: network footprint, domain inventory, technology stack, personnel, and potential entry points. This becomes your target list for tomorrow when we move to active reconnaissance. See you on day 4.